Um, dear all, dear authors and invited guests, it is my pleasure to welcome you to the 6th International Congress on Information and Communication Technology through Zoom on behalf of the ICICT 2020 and Global Knowledge Research. As every one of us is passing through this unseen circumstances due to COVID-19, we wish everyone and their families a safe time, and we will together pass this soon. Further, with immense happiness, I would like to share with you that we have received an overwhelming response this year from across 90 countries, where 1,150 papers were received and 350 papers were accepted, contributing to the success of this conference, and the papers would be published in 4 volumes this year. We are thankful to all our guests present on this platform to join us digitally for the conference in these unpredictable times and make this conference more fruitful in terms of technical knowledge, and hope you will enjoy the 2 days of knowledgeful and interactive sessions. Now, I would like to welcome you to the technical session 1E and further introduce to you the chair for this session, Dr. Shamim Al-Ma'moon, who received his Bachelor of Science and Masters of Science degree in Computer Science and Engineering from Jahangir University and Bangladesh University of Engineering and Technology, respectively. He also served as the head of the Department of Computer Science in Daffodil International University between 2006 and 2008. He has received his PhD degree in the Graduate School of Science and Engineering from Saitama University, Japan in 2018. His research interests include autonomous system, artificial intelligence, and software engineering. He has authored more than 30 papers in different peer-reviewed international journals and conferences. Also, he worked as a technical co-chair and organizing secretary at ICEE-ICT TCCE 2020 conference in 2014, 2015, and 2020. He is also a member of the IEEE USA and IEICE Japan. Now, to start with the first presentation by Dr. Najwa Hassan, who will present the neural network-based TID controller for wheeled mobile robot trajectory tracking. Dr. Najwa, the floor is yours. We can move on to the next presentation. Dr. Jan Troyer, who will present controlled social network adaptation, subjective elements in an objective.
Hi. Hello, good afternoon.
Hello.
Hi.
Hi.
Hi, I'm Najwa from India.
Oh,
sorry,
okay.
I'm a bit late to join.
All right, no problem.
Okay.
So the floor is yours. We have 15 minutes, 12 minutes for the presentation, and then 3 minutes for the questions.
Okay, thank you.
So the floor is yours, and you can share your screen.
Okay. Am I audible? Hi, am I audible?
Yeah.
Yeah. Okay. Good afternoon, all. Myself, Najwa Hassan. I'm a research scholar at the Department of Electrical and Electronics Engineering, and I am here to present a part of my research work that is entitled Neural Network-Based Tilt Integral Derivative Controller for Wheel Mobile Robot Trajectory Tracking. So this is the outline of my presentation. So basically, firstly, we have an introduction about a wheel mobile robot, what are its main applications, etc. So we all know that in nowadays, humans are replaced by robots in almost all the fields. For example, we can say that in the field of transportation, such as self-driving cars, defense applications, medical field, etc. In almost all the fields, we are replaced by the robots. And the major factors behind that, the robot has the ability to integrate various process control, and they can handle various unstructured environment, hazardous environment, etc. So because of these factors, the humans are replaced by our robot. So in order to be used in these various applications, the robot has to perform various tasks, and it has to be navigated. But that means it is required to travel freely in a static or a dynamic environment. So basically, we can say that robot navigation is nothing but refers to the ability of a robot to know its position, and at the same time, it has to plan a trajectory towards its target position, and we should have a tracking algorithm so that it can move through the planned trajectory. So the major two components of a robot navigation is the path planning algorithms and the trajectory tracking algorithms. So when a path is planned, it is essential to have a motion control algorithm or a trajectory tracker so that the planned path is tracked. So we require a highly robust control algorithms so that a safe navigation is ensured for our robot in various environments. So the major motivation behind this work, we can say that the conventional feedback algorithms, control algorithms such as our PID controller, etc., when our external disturbances, etc., occur, these conventional algorithms fail to achieve the desired performance. So in the case of a differential drive mobile robot, we can say that it's a non-holonomic and a non-linear system. So it behaves in an unpredictable way. Similarly, there are a chances of parameter uncertainties, etc., will occur, and also presence of unknown frictions, external disturbances, and all this may occur, which will affect the accuracy of our tracking, or the control accuracy is affected. In the case of robot with payloads, when the payload vibration increases, this also affect the accuracy of the robotic system, and it will create a disturbances to the robot controller, which will affect the overall stability of the systems and also affect the execution time of the whole operation. So we require an adaptive control algorithm or a trajectory tracking control algorithm so that the reference trajectory is tracked even in the presence of external disturbances. So in order to overcome the drawback of our conventional control algorithms, we have developed a trajectory tracking controller such that the wheel mobile robot can track its desired trajectory with least tracking error. And here it is a tilt integral derivative controller whose parameters are adaptively determined using a neural network. And also when it is compared with the conventional controllers, it has less control input and total control effort, at the same time less tracking error. So before going to the controller, let's see what is a trajectory tracking of a wheel mobile robot. Consider a two-wheel mobile robot such that it is having a linear velocity v and angular velocity omega, and this is our reference trajectory. We have to ensure that our robot is moving through the reference trajectory, since it is at a currently its position is x of t comma y of t, and it has to be tracked this reference trajectory, which is given by xr of t comma yr of t. So our aim should be, or the tracking problem is nothing to make the distance error, also at the same time the deviation angle 0, and the error vector is defined nothing but the difference between the reference pose and the current pose. And the error in distance and deviation can be obtained using the equations 1 and 2. And this is the idea of the proposed controller. We are having a reference trajectory. we are having the TID controller here and the wheel mobile robot. It is considered both the kinematics and dynamics of the wheel mobile robot are considered here. And here we are having a proportional controller. And here we have two errors. That is, we have a distance error. At the same time, we have error in angle. And the distance error is compensated using a TID controller, whereas the angle error is corrected using a proportional controller. And the TID controller is similar to that of a PID, proportional integral derivative controller, but it has a better rejection ratio and more better performance while compared to a PID controller. Here, the parameters of the TID controller, that is KT, KI, KD, are adaptively determined using our neural networks rather than fixing a trial and error approach or any other method. It is determined adaptively using our multi-neural networks so that our reference trajectory is tracked by the wheel mobile robot. And the tilt integral derivative controller has a parameters which are determined using the neural networks, and the input to the TID controller is the error in distance. And the main idea of using a TID controller is to prevent the robot such that it prevents the robot drifting from the desired trajectory, and thus it minimizes the tracking error. And how next see how we are training the neural networks. That is, we are using a neural network in order to obtain the parameters of the TID controller. And the neural networks are trained using a backpropagation algorithm. That is, we are having a target value and as well as the output. And the training is performed until the cost function is minimized. Cost function is nothing but the difference between the target as well as the actual output. And this trained network are used to obtain the value of our parameters of the TID controller. And the input to the neural networks are the reference trajectory, control input, and the current position of the robot. And the output of the neural networks are KT, KI, and KD. And when the error is provided to the TID controller, using these parameters, this KT, KI, and KD, it obtains the control input, and the transfer function is given by equation 3. So in order to evaluate the efficacy of the different efficacy of the proposed controller, we have developed or modeled the neural network based controller using a MATLAB, and its effectiveness is validated using by considering different trajectories such as circular trajectory, lemniscate trajectory, B-spline trajectory, straight line trajectory, etc. And also its performance is analyzed by comparing with our conventional PID and TID controller. Here, this is the result for the tracking of a circular trajectory. We can say that almost the desired trajectory is exactly tracked by our neural network based TID, and while compared to our conventional PID and TID controller. So here also, here we does not require to trial and we didn't require any trial and error approach to fix the values of the parameters. Here, even in the presence of external disturbances, which here I have considered a Gaussian noise as the external disturbances. Here also our NN based TID performs very well while compared to other conventional methods. And here we can see that the control input is also less well compared to the TID and PID controller. And this is the case for a lemniscate trajectory. Here also the path is exactly tracked by our proposed controller while compared to the other two conventional methods. And also the control input is less. And here, this is the case of a B-spline trajectory. And we know that when we are considering a wheel mobile robot, they cannot make sharp turns. So we go for this spline-like trajectories. And here we can see the PID and TID controller deviates from our desired trajectory, whereas the neural network-based TID controller almost tracks the desired trajectory. And also the control input is less. And this is a comparison is made between our different controllers while tracking the circular trajectory, B-spline trajectory, straight line trajectory. While analyzing all these results, we can say that the maximum control, total control effort, integral squared error, and integral absolute error all are minimum for the proposed controller while compared to the conventional control algorithms.
You have, Dr. Najwa, still 2 minutes, just to inform you.
This is the case of a straight line trajectory and the comparison of controllers for the straight line trajectory. And so to conclude my work, I can say that we know that the differential drive mobile robots are highly nonlinear and they behave as an unpredictable way. So in order to control these wheel mobile robots, we require an adaptive controller. So a neural network-based tilt integral derivative controller is developed such that its performance is better while compared to the conventional controllers, even in the presence of external disturbances and parameter uncertainties. And this method has exhibited superior performance with respect to tracking error, total control input, and maximum control input while compared to the conventional methods. Okay, thank you.
Okay, now we have 3 minutes for any questions for Dr. Najwa. We can drop the questions in the chat forum, or you can unmute yourself and ask her the question.
May I have a question, please?
Yes, of course.
Yeah. Thanks, Najwa, for your nice presentation on navigation and formula.
Thank you. Okay.
And I have a small doubt is that how you measure the conventional PID and PID performance on your system. Is it you tested your performance on your system, or you take the data from others' conventional systems?
I have used the conventional PID controller to track the reference trajectory that I have used for my proposed controller. And I fixed the parameters of PID controller using Ziegler-Nicholas method. And I have fixed that values. But in the case of an external disturbances such as noises, etc., occur, it cannot provide the desired performance and the system become unstable while using this conventional controller. So I require a adaptive controller, and the best performance is obtained in, for the proposed controller, where the parameters are determined adaptively rather than fixing them as a constant value.
Okay, right. Thank you.
Okay,
thank you.
Any other questions?
That's it, Mohammed. We can move further now.
All right. So the next presenter will be Dr. Yan.
Yeah.
Yeah, just okay. That will be Dr. Yan Troyer, who will present controlled social network adaptation, subjective elements in an objective social world. Dr. Yan, it is your, the floor is yours.
Do you see the screen?
Yes, we can.
Yes.
Okay, then let me start. So this talk is about modeling social networks, but then in the sense of adaptation, how they adapt over time, and also how you can have subjective elements in that, individual subjective elements. The idea is that we have a modeling approach that's, say, from network science, you can say, where you have networks that are represented by a number of characteristics like connectivity, aggregation, and timing. I will talk about self-modeling networks. That is a type of network where you represent by self-models part of the own network structure, so that you can easily handle the network structure as well, not only the states of the network. And then I will discuss three-level architecture, where you also have control about the adaptation, and I will show a social network for bonding based on homophily, but in this case, the subjective-based homophily. Let me see. So the modeling approach is based on network characteristics like connection weights, which is a bit familiar, I think, but also the function, say what I call a combination function, to aggregate impacts from different sides. That's also a parameter, a characteristic of the network structure. This is a bit similar to the notion of activation functions in networks. And I also have separately speed factors for timing of states that you can do separately, so that you don't need any form of synchronous processing. You can make them asynchronous like you want. There is a library of combination functions for the aggregation, and there are some familiar ones like the sum function or scaled sum that's often used in social network modeling, especially for the spread of information or social contagion. But also logistic functions, like often used in neural networks, they are also available. The library has currently more than 40 functions, and it's even possible to compose functions in the mathematical sense to create new functions out of them. And you can also add new functions, by the way, as yourself too. So that's the idea. That's how does that come to simulation? That is these characteristics that are defined in table form, standardized table form, like role matrices. And then it's based on. Do you still hear me? I see some messages about muting.
No, we can hear you, yeah.
Okay. Yeah.
No, we can hear you.
Okay. Yeah, so based on these characteristics, there is a standard in the software environment. There is a standard equation that, if you look well, you can see a little bit the form of a recurrent network-like equation, where you only also have the own states involved in it, and the differential equation. So this is generic equations that are used for all types of applications. How you use them is by filling them always with the appropriate combination function, the appropriate speed factors and connection weights. But the filling is just done by way of these role matrices. So you don't need to do that on a programming level. So these are all impacts that have impact on certain states Y. But then the next step is that how can you do adaptive networks? Because then also the structure has to change, and with changes within the network, you can, in principle, not change the structure of the network. So that needs some special feature that I have that also. That's called a self-modeling network. And how can you do that? You add a self-model. That's a subnetwork where some states represent certain network structure characteristics. Those network characteristics that you want to have adaptive, you add extra states for them. And then, for example, you can have a self-model for connectivity, for aggregation, for timing, and suppose we have a connection weight, we want to have that adaptive. We have some excitability threshold, maybe, that we want to have adaptive, and some speed factor we want to have adaptive. Then we just add states for them. And now we refer to them in the logical way like this, but they are just names. So that's what you call self-model states. And the self-modeling network incorporates these states and connects them in certain ways to the already existing base network. And I will discuss now the idea about the social network modeling. And one thing which is often considered in adaptive social networks is the bonding. How do connections between persons change over time? And then especially this is one important topic in literature, bonding by homophily, which can be described by birth of a feather flock together. That means if you're a bit more similar, then you have the tendency to strengthen your connection to each other. And that there are different variants of formulating it. Being alike leads to stronger connections over time. For example, you can both prefer watching Netflix series, and then maybe therefore you develop more strong connection. Because of that, I will use this as an example later as well. But normally the modeling of bonding by homophily is applied just based on objective states. So the objective fact, whether or not you are often watching Netflix series, not on what the other person thinks you are doing. And everybody knows that the image the other person has of you often is manipulated. You try to show better than you really are in general. Most people do that, especially when you have an interview, for example. But also in relationships, you do that often, that you try to exaggerate your positive sides and downplay a little bit, maybe your not so positive sides. So therefore, this objective states is not the real criteria for your bonding, because your bonding is more based on how you think the other person is and how you think you are yourself even. So that's what we do here. We take subjective representation of each other as the basis for the bonding. So this is the bonding by homophily still based on objective states. We have, these are the objective states, like these are states like how often you watch Netflix series for different persons. And then there is a connection to this person, and that is now modeled in the self model, because this is now the self model. This represents the connection weight of this connection, this W state. And because we have it now in the network as well, we see it is influenced by both sides, and it has influence back on this state. And I will show in a minute how you can define that by a specification, an aggregation specification. That's this one. So that's a combination function. This combination function, I will just briefly explain it to make it clear. So birds of a feather means there is a high extent of similarity. And that's modeled like there is some tipping point. If you have like 0.15, for example, if the difference between the two of you is less than the 0.15, then you are considered as being birds of a feather. You have a high extent of similarity. If it's higher than the tipping point, not. So that's, you can just rewrite it like this, and then this is part of the formula here. So this is, so if this is positive, if you are a bird of a feather, if you're similar, this is negative if you're not. So that means that something is added to the already existing value, W here, which is positive if you are birds of a feather. So then indeed you flock together, you get a closer connection, a stronger connection. This is a bit of explanation of this formula that is used here. There are different forms as well. I have some chapter in my recent book of 2020 about a number of them.
One more minute, Doctor.
Sorry?
Sorry for the interruption. One more minute.
One?
Well, yeah.
So this is the overall architecture. There is a self-model on this level of the basic model. And this is a self-model of that level. So this is a second order self-model to do the control. Let me first do this is the example. So this is two persons which have their own levels of Netflix addiction or so. And then the social contagion is on this level. Now this level is the representations. You make the representations of by observation and by communication. So this is the observation and this is the communication. So then we have the formation of these subjective state representations. Then this part makes the bonding. These are here. And these are the control states that control this whole thing. So this is controlling the communication, and this is controlling the observation. And that means that these channels are opened by them. So that's how these things work. So we have downward connections to open these channels and these. So let me finish then with a simulation where you can see how it works. This example is an example where there are two couples with some friendship relations. And these ones, they both like watching Netflix series, and these ones they don't like. And that leads to a different situation over time. So these become stronger and these becomes weaker. So this is the graph of it. So these are the Netflix likings levels of different persons, of the Mark and Jenny in this case. This is the not liking Netflix, these two. And then this is the bonding of Mark and Jenny, these two red lines, and this is the bonding of the N and the on. These are the blue lines. And so they're back and forth in both directions. And you see that indeed there is an increase in that because they are below the tipping point with the difference. And the difference between these two is much more than the tipping point. So therefore, these connections, they just go down. So that's how the patterns looks like. And then I finish with the control side. So this is how the formation of this is still the bonding here. This is how the control states come up here. And then the formation, because of that, the formation of the representation states are there for communication in observation both. And then we have the two. And then as soon as they are really there, you see that the bonding starts to grow. So that's all. So the general approach gives many application possibilities. A number of them you can find in that 2020 book that I mentioned. This one was about social networks, and you can represent in a declarative manner the by mathematical functions and relations, all dynamics and adaptivity and control, say higher order adaptivity in this format. So you can find some references here. There is also a YouTube channel on self-modeling networks. If you search for that word in YouTube, you will find it, where there are more things to see. Okay, thank you.
Thank you, Dr. Jan. Any questions? Okay, if there are no questions, next will be Dr. Darko Andrusek, who will present application of machine learning methods on IoT parking sensors data. Dr. Darko,
good afternoon. Good afternoon. Do you hear me?
Yes, we are hearing you very well.
Okay. Do you see the screen?
Yes, we can.
I'm Darko Androcec. I'm assistant professor from Faculty of Organization and Informatics from University of Zagreb. And together with my co-author, Dražen Vuk, which works in Mobility's company, we have written the paper Application of Machine Learning Methods on Internet of Things Parking Sensors Data. Smart parking is nowadays one of the most important Internet of Things usage scenarios in urban environments. Many people have problems how to find available parking spot in a city. So many companies offer different parking sensor and appropriate parking cloud solutions to meet this problem. One of these companies is Mobilis from Croatia. It has more than 4,000 parking sensors installed worldwide, and also it has its own parking cloud solution and mobile application. So theme of our paper was to apply machine learning methods to detect whether a car is above a specific parking sensor. We have used XGB boost and different architecture of artificial neural networks. The current detection in production system uses a classic software algorithm on the sensor itself and on the server. On the server is performed check based on the history of all parkings for a particular sensor. And in this way, the algorithm concludes whether the space is free or occupied. In this work, we show that more accurate prediction is possible by using some machine learning methods. You can find related work in our article. We have reviewed smart city services that are driven by Internet of Things technologies. Also, there are many works on applying machine learning methods in smart city scenarios. And there are also many works on machine learning and its application in smart parking area. We have used data of narrowband parking sensor manufactured by Mobilisys, where my co-author works. It's an autonomous wireless compact sensor for monitoring the occupancy of parking spaces. It's based on magnetic values. We have obtained the data. It's about 40 gigabytes of data. Each sensor has two magnetometers and temperature sensor. And also for our supervised learning, we also put in our database detection of the presence absence of the car about the sensor, the parking time, the location code, and sensor MAC address for each data row. There are some problems with raw data from these parking sensors. The sensors were calibrated, but the calibration of the sensor is stable only at the temperatures at which the calibration was performed. So when we have different temperature, it changes the magnetometer value, and its magnetic reading can be more than 150 milligauss, which is equal to the change in a situation where the car is above the sensor. And in each sensor, this change is different in relation to temperature and environment. The problem can be manholes, metal fences, neighboring cars that do not park according to regulation, metal dust falling from the car, power lines, and everything else that can affect this magnetic change that is evident by this sensor. Current detection using classic algorithms and history data is about 97% accurate. And in this work, we will show that more accurate prediction is possible by using machine learning methods. We have chosen two main methods, different neural network architecture, and XGB Boost, that is state-of-the-art gradient boosting decision tree algorithm. You can find a complete Python code for this article publicly available at GitHub repository. First, we normalize the parking sensor data. So we also mentioned that these data are very different. So we used min-max normalization algorithm to map all the data to the range from 0 to 1. Next, we have chosen data, some example data for training and for testing. We have used 100,000 instances of data, first for XGB Boost algorithm, and of which the first 90,000 data are reserved for training, and the second part of 10,000 will be used to test machine learning accuracy. Then we tune the XGB classifier parameters and get a score of 94.19%. That was a little bit disappointing because it was less accurate than a classical algorithm. We then try our model only with one sensor. Then machine learning gives slightly better result, and the accuracy is to 97.4%. But on the other hand, it is almost practically impossible to train the model for each individual sensor, for example, for 4,000 sensors or more. And also we look at feature importance by using library in Python. We then try neural network models. Also, we have used the same data, 90,000 instances for train set and 10,000 instances for test set. We have used grid search CV2 to tune the parameters. The most important were optimizer algorithm, initializer, epochs, batches, and activation functions. And on the end, we have used the following layers: sequential, LSTM, dense dropout, and simple RNN. The result was again disappointing, only 68.91%. And when we train a model with only one sensor, then the result was better. It increases to as much as 97.83%, but it is infeasible to train separately for each sensor. Then we try other methods to improve results, and pre-processing of data was the our main solution. So we prepared raw data in a way that values of magnetometer when there is no car on a parking lot are similar regardless of their magnetometer calibration, temperature drift, or sensor orientation. The idea was to make an algorithm similar to data clustering and to apply to each sensor individually. That would mean that any magnetic change should be stored in a memory or in database, and for each new magnetic value from the sensor, we should look for the most common value in the database with a specific temperature, because temperature has a large effect on the value of the magnetometer, and the most common value obtained for each axis separately should actually be a reference to when the car is not above the sensor. Then when we have a specific value, we subtract it from this reference value and see if it is near this value. If it is near this value, then we conclude that the parking space is available. And when this difference is bigger, then we conclude that there is a car there. So we use this pre-processing and try again to train with our algorithms. This pre-processing method significantly increased our accuracy and enable our XGB boost and our neural network model to have more accurate prediction. Using Keras model, we achieved the accuracy of 98.08%, and XGB boost model gives the accuracy of 98.57%, both a better result than 97% using classical current non-machine learning methods that are used in mobility smart parking solution now in production. So we achieved the better accuracy. To conclude our work, smart parking initiatives are one of the most popular smart city use cases. We have shown that machine learning algorithms can achieve better accuracy than classical approaches, and we will use it in production. There is one limitation of our approach for this pre-processing step. We must have some parking history data for a specific parking sensor. So when we have a new parking sensor, we need 3 or 4 parkings to get this reference value. In our future work, which we will try to apply our models to other parking sensors data, we will try other state-of-the-art machine learning algorithms. So this gradient boosting decision tree was good in our work. So we will try the similar, like light GBM cat boost and various other architecture of artificial neural networks, and try further data pre-processing and post-processing. Thank you very much for your attention, and if you have any questions, feel free to ask.
Thank you, Dr. Darko. So we will take questions now. Okay, if there are no questions, now Dr. Peter Romerosa will present Teacher Agency Navigating the Virtual Learning Environment in the New Normal. Dr. Peter, the floor is yours.
Good day. So let me share with you my PowerPoint presentation. Do you see it now?
Yes, we can.
Okay, do you hear me well?
Yes,
Am I clear to you? Okay.
Yeah.
Okay, so good day, everyone. I'm Peter Ramirasa with my colleagues Ferdinand Sidaquata, Maria Teresa N. Rivera, and Eduardo Udelapus Jr. from Arellano University, Philippines, and our paper is Teacher Agency Navigating the Virtual Learning Environment in the New Normal, Technology on Learning. So this is actually the sociocultural dimension of virtual learning. So for the context, the impacts of the pandemic on education. At a global scale, in the wake of global pandemic, education systems around the world are facing an unprecedented challenge of massive school closures, transitioning to online remote courses, part of the public health efforts contain the spread of COVID-19. In the Philippines, the impositions of community quarantine protocols compelled educational institutions to implement policies on distance learning. So the Department of Education implemented diverse learning modalities for distance learning. These are online digital modules, offline digital modules, printed modules aided by television, radio instruction, and embedded learning and homeschooling. For private schools, the primary learning modality is distance learning or online learning rather. And for public schools, the primary learning modality is modular instruction. These are the debates. The non-voluntary transpositions into virtual classes heightens digital device in terms of how to access internet connectivity, gadgets, and digital knowledge. For middle, middle income countries like the Philippines, the internet connectivity is not stable in some provinces, particularly in those far-flung areas. Another debate, the Philippines has no national policy to support online learning. Higher education institutions are left to implement online classes without implementing rules and regulations from the national government. So there is now an issue of equity and equality because the forced adoption of online learning poses serious challenges in terms of why, how, who, and what to teach, including how learning can be accessed equitably. So responding to this, our school implemented for the first time the learning management system as its primary learning modality during the pandemic. And as an instructional approach, the teachers were instructed to make video lessons. With the heightened disparity of students' access to changing education paradigm, the teachers are called to exercise agency, reflecting contextualized strategies to address problems. So we framed the study using the concept of teacher agency by Gesta Tedder and Tedder. So teacher agency refers to our capacity or teachers' capacity to critically respond to challenging situations and the ability to exercise decisions in everyday practices. So this is how we frame our study. On the one hand, there is this policy. By default, it has affordances that structure learning and teaching. And part of these are video lessons created by the teacher. On the one hand, there's this notion of agency at the classroom level. Teachers negotiate, interpret, and contextualize the policy in order to meet the needs of students. As a result, the negotiation or the relationship between the policy and agency have resulted in diverse learning models and strategies. So the main objective of the study was to describe the experiences of teachers navigating the virtual learning platform in terms of how agency is exercised, constrained, and facilitated, and what alternatives can be drawn to improve the LMS policy. So we use a case study approach to explore the complex phenomena within the teacher's context, using a variety of data sources and lenses to uncover multiple facets of phenomenon to be understood. So these are the results and discussion. This reflects how teachers from different levels negotiate the policy. So the issues are for a kindergarten teacher, how to get the attention and make the class interactive, considering that during the face-to-face traditional teaching, um, that mode of teaching requires a lot of direct observations and physical interactions. But in here, according to the teacher, her narrative, I tend to be more expressive with my actions, facial expressions, and manners of speaking to get my people's attention and encourage them to express themselves. So they're trying to establish an identity of being a teacher online that sets them apart from the identities of bloggers. And another exercise of agency is responding to the feeling of anxiety because of parents' presence online. So the agency there, the teacher realized that when parents are involved, they get to know their child better. They cooperate with teachers and suggest ways on how to improve teacher-parent communication for the improvement of people's attention. So another issue here uh, was limited access to digital information, and the exercise of agency was forming online networks that facilitate sharing of resources, navigating different online platforms like teaching how to use Zoom, Google Meet, Facebook Messenger Room, and making of videos. So they learned that through creating networks like this, teachers become sensitive and um, they become um, uh, they learn how to be caring and empathize with each other. So another issues here has something to do with poor internet and limited load, as well as mastery of the lesson. So the teacher then group students according to their needs, and the grouping was complemented with modules in order to save load and address the issue on poor connectivity. The teacher gets to meet students once a week, while other students are busy or doing their modules during asynchronous sessions. So the modules are designed to facilitate spiral progression of learning. So this is the contextualized framework. So the relationship of policy and teachers' responses to policy reflect pedagogic agility, hybridizing, bricolaging, and in local term in Filipino language, we call it discarded. So pedagogic agility is the ability of teachers to demonstrate flexibility by making quick but meaningful decisions. Hybridizing is innovating the familiar around previous practices and values that are just. Bricolaging is adapting to the situation and creatively employing available resources, materials, and strategies to produce a solution to a problem, rather than adapting what the community prescribes. So in here, teachers created their own strategies that are not prescribed by the policy. And with this, discarte, a local term to describe the ability to make creative improvisations or strategies, allowing to leverage the imposed pedagogical structure and manage to meet teachers' agenda. Thus, teachers are co-constructors of the learning environment and educational policy. That's it, and thank you.
Okay, thank you, Dr. Peter.
So we have questions.
Any questions? Yeah.
May I ask a question?
Yeah, of course.
Yeah, sure.
Yeah. So, thank you very much, Peter Ramorosa, from
Thank you.
Philippines, right?
Yes, yes, from Philippines.
Okay. I think in your country the education systems have different level in primary
Yeah.
or tertiary and higher education. These three levels.
Yes.
So, did you ensure the inclusive learning method on this on your system, or did you incorporate the what can I say the inequality learning processes for the learning disabilities peoples? Okay, did you have any inclusive method for that one, for agency for your educations? Because in your system.
Okay, so my internet's not stable. I don't know if
Okay. Uh, I repeat my question is that would you consider the inclusive learning method to adapt the teaching pedagogy, or
can you please
how you
type your
actually
question? Can you type your question?
are you listening to me now? Is it clear?
I don't hear clearly the question, so you can type it so I can understand
Okay,
it.
okay.
So
I will personally message you
reception is poor.
questions, so you would answer on that chat box. Okay.
Ah,
Thank you.
so yeah, but I think Yeah, here in the Philippines, we for public schools they use modular printed. For private schools, they use digital online learning. But the problem is, it's our first time to adapt the online learning. So
Yeah.
teachers on the ground trying to create their own strategies in order to reach out to students, because the major problem in the Philippines is that the internet connection is not stable, particularly in some provinces. Uh, so that's the major problem. So the teachers are trying to address that problem, and from the strategies, we're trying to come up a policy to integrate what's happening on the ground and how they're trying to respond to these problems by creating their own solution strategies.
Okay, right. Uh, Actually, my question is that in the physical classroom, you can solve the learning disabilities of the students, but how you uh, ensure that the students, those who have the learning disabilities, on online platform in your
Yeah,
system?
yeah,
Okay.
yeah. That's actually the biggest issue, because in the basic education, preschool, elementary, and junior high school, that requires a lot of interactions, movement, direct observations. But according to the teachers, their practices before the pandemic that they that they perceive to be effective, relevant, they transpose them. However, it's limited. That's why they're creating rules, at least to meet the needs of students. So, like for example, in one case, she's trying to exaggerate her facial expressions just to make sure that they have contact with students. And at the same time, they're trying to involve parents so that parents can teach students uh, at home. But that poses another problem. Parents are not usually teachers; they're not education graduates. So that the teachers are trying to give them seminars, trainings as well, and they're trying to open the communication between parents and teachers to ensure that they can share knowledge on how to educate students at home. So, and we're trying to look into that.
Okay, okay. I got my answer. It's okay. Thank you very much.
Thank you.
Thank you.
Any more questions? All right, now Dr. Petri Oksa will be presenting obtaining AROS-based face recognition and object detection, hardware and software issues. Dr. Petri, the floor is yours.
Yes. Okay. Can you hear me?
Yes, we can.
Okay.
No problem. We can call you back for the next presentation as we are running short of time.
Okay. Okay.
We have to.
Yes.
So we'll call you for the next presentation. We can call the next presenter, Mohammed.
Okay. Now, Dr. Bilal El-Ayeb will present mono and cross-language information retrieval based on analogical proportions review. Dr. Bilal, the floor is yours.
Dr. Bilal, I have made you the co-host so you can start sharing the screen.
Yeah. Is it clear now?
Yes, it is.
Just 1 minute for the full screen. Okay, thank you very much. Today I will speak about literature review on mono and cross-language information retrieval approach using analogical proportion. The outline of my presentation is the following: introduction and motivation, why I will present this literature review, a short background on analogical proportion, then analogical ER and declare approach. I start by presenting the standard metrics, used by the proposed approach or the existing approach, supervised analogical yard clear approach, then unsupervised analogical yard clear approach, then ODA ER clear approach, open problem and the future direction, at the end, the conclusion and the future work. The introduction and motivation here, analogical proportion, are known. Analogical proportion here are known to be a formal representation of this kind of reasoning, are efficient in comparing cases stated by differences that are equated to other difference. Analogical proportion has already shown their efficiency in modeling morphological linguistic analysis in 2005, information retrieval, my approach in 2019, text summarization, my recent publication of 2020, classification also, preference learning in 2019, and dataset expansion. Analogical proportion has achieved significant results in terms of complexity and accuracy. The existing reviews and surveys related to the domain of analogical proportion and learning are limited on the book of Computational Approach to Analogical Reasoning, Current Trends of Pratt and Richard in 2014. It includes 3 survey or review papers, the relationship between analogical proportion and analogical reasoning, also a review paper of Pratt and Richard 2017, a new perspective on analogical proportion, the Barlott paper of 2019. The existing reviews and survey works are not dedicated to survey particular domain of applications such as RER and Declare or NLP. There is only a few number of existing research works in the domain of analogical ER clear, and most of them are relatively outdated. There is an intuitive relationship between the domain of application of analogical proportion, such as NLP, ER, and Declare. That's why you are interested in this paper to review the domain of analogical ER and Declare, which is not being reviewed up to date. I provide here background on analogical proportion. Analogical proportion are known as the statement of the form A is to B as C is to D. That we denote A, B, C, D. This relationship expresses that A differ from B as C differ from D, as well as B differ from A as D differ from C. Making the assumption that item A, B, C, and D form a valid analogical proportion, and giving that item D is unknown, this is the basic route for extrapolation enabling to get the fourth item D based on the values of the triple ABC. I give the example here, which differ the B to the honey, differ the cow to the milk. Same for the shape here, the square with this corner in black. Here, the circle, it should be a corner with a black and at right. For a Boolean variable, the analogical equation A is to B as C is to D can be written as the Boolean equation. It uses the similarity indicator only. Among the property of this equation, A is to B as C is to D satisfy the reflexivity properties, symmetry, central permutation, external permutation, and transitivity. Analogical proportion truth table, given the 3 item ABCD, we have 16 possible combination, only 6 of them has a solution. A differ from B as C differ from D. So 0, 0, 0, 0 is a valid equation. Same here, 1, 1, 1, 1 is a valid, 0, 0, 1, 1 is, and so on. Generalization for the nominal setting here. If A, B, C, D take their value in a finite state U, if UV in the finite state U here, the item UU, UU, or UV, UU, VV, or UV, UV are valid schema. That means that the analogical proportion has a valid solution. Analogical inference here, the definition of analogical inference, or the goal is to find the solution to the equation A is to B as C is to X. The equation A is to B as C is to X may not have a solution in B. So let me give the example 0, 1, 1X, nor 1, 0, 0X have no solution. Okay? When it exists, A should be equivalent to B, or A should be equivalent to C. The extension to the vector context, we can apply to Boolean vector, X with the X1, Xn item. So the analogical equation in terms of vector, vector A is to vector B as C is to vector X holds to solve an equation corresponding to their item. II is to BI as CI is to XI. Here, I will present the literature review. I summarize the context with this figure. Analogically, a clear approach may be machine learning based approach or others. For the machine learning based approach, the supervised analogically are clear. We have the two works of Longley-All on 2009 and Obun Hassan Al 2019. 3 unsupervised analogically are clear and 2 others analogically are clear approach in the literature. All these approach 3 used the standard or the classic assessment metric for ER and clear, such that precision, recall, F-score, mean average precision, exact precision, the blue, the NIST, or the word error rate. Let me now detail the approach for supervised analogical ER clear approaches. Longley-All on 2009 have proposed and implemented the solver for some practical problem in analogical learning. The author have suggested an efficient search technique based on analogical learning and outperform some existing search strategy. Besides, the proposed classifier is trained to generate suitable candidate translation for multi-term of medical domain. This classifier outperformed the most frequently generated heuristic involved in many approaches on analogical learning. Is translation in 5 languages to English, and this is the best results in terms of precision and recall. The second approach of Bunhas and al. In 2019, they have proposed an analogical ER matching model. The author investigated the analogy between new test query, training query, and their known sets of relevant document in order to build the unknown set of relevant document for a new test query. From a logical point of view, one may assume that why differ on query to another in terms of indexing terms should also affect their corresponding relevant document. Here, the standard metrics used are the mean average precision, the recall, the R precision also, or the exact precision, the precision at level A, and the percentage of improvement using the 3 data sets, CRAN, KCM, and CIS, chosen because they have similarity between their query. I compute here a percentage of improvement in terms of map R precision and precision at top returned document for the 3 data set, CRAN, KCM, and CEIS. Regarding here the unsupervised ER and declare approaches, the analogical query expansion approach of Muru and al. On 2007 has been dedicated to detect morphological variant of a given word to be exploited for a query expansion process. They have tested their approach using English-French dataset in addition to question-answer collection for 6 languages. This is the best registered results. The second one regarding the unknown word translation, the analogical proportion of Longley and Patry in 2007 has achieved significant results also by successfully translating about 80% of ordinary unknown words in French to English translation tests. This approach has been extended to perform suitable translation for unknown phrases also. So they used Europal corpus and the projects indicate the total 441 unknown words. For the French language, the results in terms of precision recall and word error rate. For the Spanish and German also. The last unsupervised one is the analogical translation approach of medical word of Longley and all on 2008. It has been assessed using various data sets in different languages. The proposed approach is able to identify suitable translation for unseen words. The analogical inference consists to form analogical equation combining 3 known words that make this equation solvable. They have tested using all these set of data set computing. The best precision is about 81% and the best recall is 55%. Now the others analogical ER clear approach which are not based on machine learning algorithm. Lepage and Denoull in 2005 has developed an analogical machine translation system denoted ALIF that has been tested using the IWSLT 2004 Compiègne. The ALIF system shows its efficiency as a machine translation system without requiring any NLP tools such as Tagger. No dictionary is used also to support the corpus sentence example. It is also independent of any tokenization device. ALIF does not use any distance between example nor any threshold. So it is tested using the C star corpus. These are the results for Chinese English translation and Japanese to English translation using the IWSLT dataset. Here's the IWSLT 2005 for the Korean English, Chinese English, Japanese English, Arabic English, to Chinese also. Finally, the analogical proportion has been exploited also by Denoull in 2007 to translate a known word as a string of character, while the classical machine translation approach still perform the translation at the level of word. The proposed analogical translation approach seems useful in statistical machine translation context and contribute to enhance the quality of translating in known words. The standard metrics used are the blue and this. This is a variant of a blue. The author have used 500 sentences and WSLT 2006 Compiègne to assess Japanese to English translation. Best blue 0.16, best NIST 5.80. In terms of open problem and future direction here, I suggest analogical proportion in query disambiguation, which consists to select the correct meaning of a given ambiguous query term by considering the full context of the query. Then we model the problem using the analogical proportion X is to A as Z is to T. X refers to a known ambiguous word in the training set. Y refers to its known sense in the training set also. Z refers to another ambiguous query term from the testing set, which has a sense unknown, which is T. Its unknown correct sense to be identified. So the general idea is to find the solution to this kind of equation. Same for the analogical query expansion. Select semantically close word to a given source query term to extend the query context, and consequently enhance the ER or clear efficiency. Analogical query translation disambiguation. Select the correct translation of a given ambiguous source query term to disambiguate the translated query, and then enhance the efficiency of the clear system. For predicting.
Sorry, Doctor, can we wrap it up?
Yeah.
Because we are running out of time and
yes, just one slide. Predicting difference in personalized ER using analogical proportion. The goal here is to predict the difference between new pairs of items based on a set of difference between items taken by pairs. Two methods are suggested. One exploits triple of pair, and the second one only two pairs. As a conclusion, we have presented and discussed here analogical ER clear approach existing in the literature during the last decade, but only 7 approaches I have found. Only a unique recent work of Bun Hassan Al 2019. Most of the existing ER clear are unsupervised. This is due to the lack of lab-based training set, which are not usually available for different language domain and tasks. This new research trend may require some domain-specific dataset, given that analogical learning based ER model are mainly based on similar cases in training set. Let me the example of 2021, the Ant corpus, and of 2018, the Kunuz corpus. Maybe this domain-specific Arabic linguistic resource can support research effort in analogical Arabic ER clear. Thank you for your listening.
Thank you, Doctor. Any questions? Okay, if there are no questions, Dr. Petri Oksa, if you are ready.
Yes, let's try again.
Okay.
Okay.
Now we can see it. Yes, we can see it now.
Okay.
The floor is yours.
Yes. Okay, my name is Petri Oksa and I come from Tampere University, Pori, where I'm leading the autonomous robot ecosystem project. And I'm working with open source systems and Ubuntu systems and cloud services also. And the paper title is how to obtain ROS-based face recognition and object detection, and what kind of hardware and software issues can occur. And first, the abstract and the the research in a nutshell, and then motivation, why are we doing this? And then outer Robo system overview. And then it's Z2 package installation. And then it's about TensorFlow package installation. And then I will show the people recognition and mapping localization and navigation, and then conclusions and remarks, and finally future work. Okay, this is abstract, and we are using Ubuntu Linux-based system, Ubuntu 18.03 ROS Melodic and Google TensorFlow 1.13. Programming the software environment. And we have a Z2 mobile robot with additional onboard sensors and used to conduct the experiments. And entire system configuration and specific hardware modifications that were proved mandatory to make out the system functionality are also clarified. And coding, mostly Python, and sensors installations are detailed both in onboard and remote laptop computers. And in experiments, TensorFlow face recognition and object detection are examined by using Z2 robot. And finally, results show how objects and faces were detected when the robot is navigating in the previously through dimension mapped indoor environment. I don't go deep to coding and programming, and I keep this presentation to practical and hands-on type. This is why are we doing this? To overcome incompatibility problems and difficulties that can emerge system environment represented in the open source robotic platform. And we give guidelines for coding, required software package installation, and robot hardware setup also. And the main motivation is for using the TensorFlow with ROS is the need for object detection and face recognition implemented in ROS-based moving robot. And there can be many issues in the installation phase, and we try to find solutions for ROS robot platform. And primary goal is an open source robotic platform for all users that have an interest to develop the proposed system platform further. And this is the Robo system overview. This is the normal ROS network. On the right-hand side is a Turtlebot robot where we start the master launch file. We use VNC to share the desktop. And here is the sensors what we have in a laboratory. We can use this research. And on the left-hand side is the remote control. It's a normal laptop computer where is the VNC client and OpenSSH R, which is the visualization program we can use to see the robot control in the environment. And the TILOP keyboard launch file, and it's when we use to move the robot. And it's also the TensorFlow altogether launch file which charts the object and face recognition. And here is the turtleboard robot and the sensors fitted onto the robot. On the rear is the H2 LiDAR laser scanner, and the front is the RealSense sensor, and on the middle shelf is the MS Kinect sensor. And Turtlebot 2 Debian installation option is not supported for ROS Melodic on Ubuntu 18 distribution. Therefore, only way to install the Turtlebot 2 package is to download the package and build it from source code. And then the TensorFlow package installation. We use TensorFlow version 1.14, which is compatible to our laptop software, hardware architecture, and Ubuntu distribution. And GPU requirements must also take into account. And TensorFlow uses CUDA, Computer Unified Device Architecture, which means that NVIDIA GPUs are supported. And in case of GPU incompatibility, TensorFlow can be used with CPU support only as used in our installation method. And it must be noted that TensorFlow should be installed before the ROS / TensorFlow's recognition package installation. And here you can see the people recognition is the file folder where you should put the pictures. We have recognized one of our researchers here, Tero, and the pictures should be .png type of pictures. And they should be white background to get the best output. And here is mapping, localization, and navigation. And we use the Turtlebot 2G mapping for scanning the environment, and OpenSLAM for localization. And navigation we handle by using Kinect, and recognition by using RealSense. And LiDAR helps to accurate mapping. And the adaptive Monte Carlo localization for autonomous navigation. And then conclusions and remarks. And we give practical and detailed solution for each installation issue. And available source codes and software packages are utilized, such as several ROS packages from GitHub public repository, and reducing the complexity of further programming. And the main issue is there is many TensorFlow programs which cause high CPU load. And we find that it must be extended to computation capacity of onboard computer, especially RAM disk space. And then to make sure that all images are in applicable image format. And same outlines and white backgrounds coloring on all images located in people folder. And the further work. In the near future, we continue combining both Kinect and H2 LiDAR topics into a one RWidth window, producing a better QG mapping outcome. And we try to minimize of delays when using TensorFlow recognition package. Okay, that was my presentation. Thank you very much.
Thank you, Dr. Petri, for the good presentation. Any questions? Okay, now Dr. Joaquin Nito will present an ontology for fire building evacuation. Dr. Joaquin, the floor is yours.
Are you hearing me?
Yeah.
Okay. Let me share. Okay, good afternoon to everyone, and thank you all for attending my presentation, where I will expose my work, an ontology for fire building evacuation. My name is Joaquim Neto, and I am a PhD student at Universidade Aberta, the Open University from Portugal. The outline of my presentation are the points in these slides. I start with problem statement and motivation, the related work. I will talk about ontologies and development methodologies, ontology development life cycle, building the ontology herein presented, and conclusion and future work. Concerning motivation, this research work falls within the scope of our ongoing PhD thesis, in which we propose to study how a multi-agent recommender system could guide in real time the occupants of a building under a fire emergency. The fact that the proposed solution is based on an ontological model to support the interoperability between the different actors involved in an evacuation process, that motivated us to build the ontology herein proposed to a better understanding of the fire building evacuation domain. Concerning related work, the literature shows many research works in the emergency area with different purposes and approaches to model knowledge in the field of the fire emergency in buildings. Our focus, however, is the knowledge modeling of the building evacuation process, considering all actors involved, as already told. Ontologies. We present here two ontology definitions in the scope of our work. Gruber considers ontology as an artifact designed to model knowledge about a domain, be it real or imaginary, and objects, concepts, and other entities and the relationships among them are used to represent knowledge within a domain. Ontologies provide a common and shared understanding of a domain and are also promoters and facilitators of the interoperability between information systems. Concerning ontologies and development methodologies, from literature, we found as the most representative ones the four presented in this slide: TOV, Enterprise, Math Ontology, Ontology Development 101. We followed Math Ontology, and also you get some information related with ontology development 101. The ontology, all the four methodologies that I talked about considers five stages in the life cycle developing of an ontology. Namely, the specification stage, where we identify the purpose and the scope of the ontology. This conceptualization stage, that describes, where we describe through a conceptual model the ontology to be built so that it meets the specification found in the previous state. The formalization transforms, where we transform the conceptual descriptions into a formal model. The implementation, where we implement the formalized ontology in a knowledge representation language. And the maintenance, where you update and correct the implemented ontology. During all the life cycle, three activities must be considered: the knowledge acquisition, documentation, and evaluation. We are now to build our ontology. We start with the specification stage, where you look for answers to these four basic questions. What is the domain to be covered by the ontology? Why build the ontology itself? What are the intended uses? What kind of answers should the ontology give? You support the answers, the above answers, the answers to the above questions on Portuguese legislation and regulation, experts' feedback, and a set of competency questions, and also the respective answers that we show in the next slide. Based on our reading and experts' feedback, we create 11 competency questions that allows us to frame our specification, and the domain of our work. And in this slide and the next, we present them, as well as the summary of the answers. I will not read all of them. For example, how to detect the start of the fire, or what is the type of building, what is the building's capacity, what are the types of hazards, for example, toxic gases, smoke, temperature, and so on. These questions and answers helped us to construct the specification and requirements of our ontology that we show in this, that we summarize in this table: the ontology domain, evacuation of buildings under fire emergency, ontology goal, developing a knowledge model about buildings evacuation under fire emergency, the contribution of the ontology that we pretend to provide a knowledge representation about the referred domain to support the development of fire evacuation applications and systems, and also a set of answers that our ontology must be able to answer. The next stage is the conceptualization stage, where the ontology is described through a conceptual model to meet the specification defined before. It consists of concepts and in the domain and the relationships between those concepts. We use the framework MINDOMO framework, that is a mind map software, and we start our conceptual model with three main themes: building, occupant, and fire. The mind map is public, and the link is also included in the paper. The next stage are the formalization and implementation stages. The conceptual model was transformed into a formal model. The ontology was implemented in a knowledge representation language. For the implementation, we used the Protégé, a largely used open source platform that provides a suite of tools to construct and describe ontology. And based on the conceptual model, we create and describe 52 classes and 57 object properties, characterizing the relationship between them. In the next two slides, we present Protégé screenshots in this case, we have an example of a class where it's possible to see the screen where you have the classes, the annotation for the classes, the usage of the classes over the ontology, and a graph representation with all the relationships between this class and the others related with them. In the next slide, in this slide, you have
we have 2 minutes.
Okay, thank you. We have a screenshot for object properties and data properties. Concerning evaluation, evaluation is an iterative process that occurs throughout the ontology development cycle, and the ontology evaluation is a technical judgment of its content against the referential. In this case, our referential is the set of competency questions and the specification requirements that previously shown in the previous slide. The technical evaluation deals with aspects related to ontology structure, syntactic validation of classes and properties, and aspects related to documentation. We used a web tool, ontology improvement tool, which provides automatic evaluation tests and sets, namely that we show in this slide, and the tests carried out with the tools referred above were completed with success and are available for consulting on the ontology URI. Another way to evaluate ontology is evaluate it against the referential, as before told, where the referential are the specification and competency questions, and that is an example where to answer a specific question and the axioms that are obtained querying the ontology with Sparkle language. For conclusion, future work, the ontology contributes to a better understanding of fire building evacuation domain and considers the different and relevant variables and actors in building evacuation, and is a support for developing more capable building evacuation solutions and systems. Finally, as future work, we propose to deepening the ontology through use cases and reusing it to develop an ontological model to support the interoperability between different actors involved in the evacuation process as planned in our PhD thesis. And thank you. I will be available for any question.
Thank you, Doctor. Thank you for this good presentation. Any questions? All right. I sincerely thank our authors for their excellent presentations and contributions in this session, and all our participants for being part of this international congress. I hope this session was informative and knowledgeable as well. All the presenters will be getting their digital certificates through mail within 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live within 4 to 6 months. Kindly cooperate with the team of ICICT 2021 as and when intimated. I also thank I also thank our session chair, Dr. Shamim Al-Ma'moon, for chairing this session. A token of appreciation to the chair on behalf of the team, ICICT 2021 and Global Knowledge Research Foundation. Thank you for your valuable presence. And I also, I kindly ask you to turn on all your cameras for a quick snapshot of the virtual conference. Okay. Thank you, everyone. Stay safe and take care.